The old method of classifying organisms was based on their habitat or their structures, and the problem is this just had too many issues. So, for example, do you classify a sea turtle with land-dwelling turtles or with sharks that also live in the sea? Um, and so there's not really a good way to classify them that way. Additionally, what do you do with things like mushrooms that look kind of like plants but also eat stuff like animals? And so people realize we need a better way of classifying these organisms. And so changes have occurred as we have developed new technologies and developed a better understanding of how life fits together. And one of the big ones that has really fueled a lot of the changes in our classification system is genetics, because now we're able to actually compare the DNA of organisms. So nowadays what we do is we base our classification of organisms on their evolutionary relationships and common ancestry. So for example, we would put this whale in the same grouping as a cow and not as a whale shark, because the cow and the whale are both mammals and the shark is a fish. So evolutionarily, mammals are a much more closely related group than they are to fish. Now, when we do classification, we're going to break things down into what we call taxonomic groups. And so the current system looks something like this. Now, I like to show this as an inverted triangle because as you go down, so from domain down to species, you're getting fewer and fewer species and fewer individuals, but they're more related. So if you're in the same species, you're extremely related. If you're in the same domain, you're not as related. So as you go up, again, you get more and more species, but they're less and less related. Now, when we look at this, the two that are the most important for you to understand are genus and species, because this is what makes up the scientific name of an organism. So for example, the scientific name of humans is Homo sapiens. Homo is the genus, and sapiens is the species. Notice it's in italics. The genus name is capitalized and the species is not. So now let's kind of look at how all this sort of starts to go together. So who's most related in this situation? This is a DNA fingerprint. Right off the bat, you should be able to see the coyote is definitely the least related. None of these bands really match up with anybody else. Now let's look at the lynx and the puma. They've got some similarities, but not a whole lot. The bobcat, however, and the lynx have a large number of bands related. So they have the most related DNA, so we're going to say they are the most related. So let's look at how that works with taxonomic groups. So the more common groups that you have with another organism, the more related you are. So when we go down the list, we see they all have the same domain, kingdom, phylum, class, family, order family, except for the coyote. So the coyote, again, is the least related because it has the least number of groups in common. Then we see that the puma is in a different genus than the bobcat or the lynx, and then the bobcat and the lynx are in different species. Now let's see how we can do this more in a graphic way that shows common ancestry. And we're going to use a phylogenetic tree, which is essentially a family tree for species, and it shows common ancestors and how species have diverged over time. So here's an example of a phylogenetic tree, and the species at the top, these are current species. These are the ones that are currently living. Each time that there is a split, that's where the species diverge. So that is their last common ancestor. As we go backwards, we get older, and if we look at F and G, all the other species along this line are common ancestors of these two all the way up until we get to this split. That's their last common ancestor. Now if we look at this, the most related are D and E because they diverged the most recently. And the least related would be A and G because they diverged the most distantly. So again, let's look at our taxonomic group chart. And so if we think about this as far as divergence is concerned, the coyote diverged first, followed up by the puma, and then the lynx and the bobcat. So if we put this on a phylogenetic tree, it would look something like this. So this first divergence, we said, was between canines and felines, and ended up with the coyote. The next divergence was between the puma and the lynx genus, and so we have the puma here, and then the final divergence was between the lynx and the bobcat. And so all three of these things can work together. Next, we're going to look at a dichotomous key. And this uses physical traits to actually help identify organisms. And it uses a this or that. That's what di means. So it's two. It's either this or it's that. So here's an example of a dichotomous key. And we're going to try and answer the question of what is the genus of bird X? Alright, so what we do is we start with number 1, and the beak is either relatively long and slender or relatively stout and heavy. So looking at this one, we're going to say it's relatively stout and heavy. This tells us to go to number 2. So the bottom surface of the beak is either flat and straight or curved. Well, in our case, it's curved, so it tells us to go to 3. When we go to 3, it says the lower edge of the upper beak is either bent or flat. In ours, it's flat, and so Platyspiza is the genus of that bird. And that's basically how you identify organisms, classify them by common ancestry, show that in a phylogenetic tree, and identify relatedness using a taxonomic chart.